In the last video, a loom taught us that machines can follow instructions. Now, who wrote the first computer program? By program, I mean a clear step-by-step set of computer instructions. Here's the twist. In 1842-1843, there wasn't a single working computer. Is it even possible to write a program without a computer? Let's debug history. Can you write a program without a computer? Well, you can, if the machine is described well enough. In the 1830s, Charles Babbage sketched a computer he called the Analytical Engine. A few years later, an Italian engineer, Luigi Menabrea, published a clear write-up. His paper, Notions sur la machine analytique de Monsieur Charles Babbage, or the English translation, The Sketch of the Analytical Engine by Charles Babbage, is an important reference document for us. It describes three vital components of the machine: the store, memory to hold numbers; the mill, a calculator to do the arithmetic; and punch cards that tell the machine what to do in what order. In today's language, the store is like RAM, the mill is the CPU, the card deck is your code plus inputs. Some cards say the operation, some point to memory locations, some carry constant numbers. The deck can repeat a section and skip based on a result. Because instructions can be arranged, repeated, and branched, the machine is general purpose, or Turing complete if you prefer. With those rules, the answer is yes. People did write programs on paper, and in Menabrea's 1842 paper, we meet our first printed candidate, a worked method for linear equations. Menabrea's paper doesn't just describe the machine, it walks through a method for solving simultaneous linear equations. Think of two lines on a graph. We want the point where they meet. Menabrea lays out a step-by-step table, what to read from the store, what the mill should do, and where to write the result. By our rules, that looks like a program. But it's mostly a one-off walkthrough. It implies repetition without formal loops, and there is no full trace table. If your standard is first published program, this has a strong claim. If your standard is first fully worked algorithm with explicit loops and a trace, we're not there yet. Either way, Menabrea proves you can write programs on paper. Next, the translation a year later. By the way, if you find this video useful, hit like and subscribe. In 1843, English mathematician Ada Lovelace was tasked with translating Menabrea's paper. She went on to add notes A to G, longer than the paper itself. In note G, she lays out a complete machine-oriented procedure to compute Bernoulli numbers. You don't need to know the maths. What matters is the structure. Each step says what the mill should do, which values to read from the store, and where to write the result. Crucially, it includes an explicit loop and a trace table, values recorded after each step. In modern terms, load A, add B, store C. Repeat while the counter is less than n. After each pass, write down the new values. That combo, sequence plus loop plus trace, is why so many historians point to node G as the first fully worked algorithm in print for a general-purpose computer. Yes, Lovelace worked closely with Babbage. He suggested changes and had earlier drafts. We'll weigh that next. Before anything was in print, there were drafts. In the late 1830s, Babbage filled notebooks with engine procedures, equations, series, even pieces of Bernoulli's work. They predate publication. Now to 1843 and the correspondence. Ada shaping a publishable exposition, asking clarifying questions, adding examples, Babbage reviewing, proposing corrections, and sometimes suggesting organization. In a modern context, that looks like code development. You can give Babbage priority and still credit Menabrea or Lovelace for firsts in print. Different standards give different answers. Here are 3 reasonable ways to judge first program. Standard 1, priority. Earliest surviving program, even if unpublished. Babbage notes, 1837 to 1840. Standard 2, first published program. Any worked procedure in print. Luigi Menabrea, 1842, linear equations. Standard 3, first published, fully worked algorithm. Clear sequence and explicit looping plus trace. Ada Lovelace's Note G, 1843, Bernoulli numbers. So, which standard should we use? Well, you decide. If you value earliest writing, then Babbage wins. If you value first in print, Menabrea wins. If you want the first complete reproducible algorithm in print, Note G. To be honest, it matters very little who did what first. The efforts of these 3 pioneers are instrumental in the foundation of modern computing. It's safe to say that without them, computers or AI wouldn't exist. Don't we just love AI? Well, history debugged. Feel free to share the video with someone who may benefit from it, and check out these other videos about early computing right here or here. Thank you very much for watching. Cheers.